Welcome to the deep dive.
Hello.
Today, we're taking a bit of a leap, aren't we? Beyond the usual BIM conversations.
We definitely are. We're heading outdoors, so to speak.
Exactly. Exploring a fascinating new frontier, how Revit,
Hmm.
the tool we mostly link with buildings, complex indoor stuff,
Architecture, structure.
right? How that tool is now making a really significant mark in landscape architecture.
This is quite the shift.
Yeah, this whole deep dive is about pushing those boundaries, showing how outdoor spaces are getting designed and, importantly, coordinated with the same kind of precision as the buildings themselves.
It really feels like a convergence is happening. For a long time, landscape design often used, well, pretty disconnected tools. Felt separate.
Totally separate. So our mission for you today, the listener, is basically to quickly unpack why the shift is happening and what it really means.
We've pulled out the key insights from the sources.
Yeah, trying to give you a shortcut to getting up to speed on this maybe slightly surprising development,
Mm.
hopefully with a few aha moments along the way.
And that brings up a really important question. Why are landscape architects starting to embrace Revit?
When they've had tools like AutoCAD, SketchUp, standard stuff for ages.
Exactly. And the sources we looked at make it pretty clear. Revit brings in things like parametric modeling,
Okay.
deep data integration, and genuinely multidisciplinary collaboration for site design.
So it's more than just a software swap.
Oh, absolutely. It goes way beyond what those older tools offer. It sort of redefines the possibilities.
You mentioned parametric modeling there. For listeners, maybe someone designing, say, a park or a big campus. What does that actually mean in practice?
Good question.
How does it help a landscape architect in a way that, a simple drawing just can't?
Okay, so imagine you've put a certain type of tree in your design. Right. With parametric modeling, that tree isn't just a picture like a static block. It's an intelligent object.
Intelligent how?
Well, if you decide later, okay, I want to change the species, or maybe adjust its mature height,
Right.
every single instance of that tree, everywhere in your project, updates automatically.
Wow. Yeah.
And the system can even recalculate things based on that change, like
Yeah.
its effect on shade or drainage, or even the quantity needed for planting schedules.
So you're designing with data, essentially, not just lines.
Exactly. Designing with intelligence.
So it's less a software upgrade and more like a strategic shift in how outdoor spaces are conceived.
I think that's a great way to put it.
What's the biggest, maybe, mindset adjustment needed for a landscape architect moving over to this approach?
Yeah, the biggest shift is probably moving from drawing representations of things like this line as a path
Right.
to actually modeling components that carry real data.
Okay.
It means thinking more holistically right from the start, considering how the ground, the topography interacts with the planting, how hardscapes connect to stormwater management, how it all ties back to the building systems.
Creating like a unified digital twin, almost, of the site.
Exactly. That's the goal. This comprehensive integration, topography, plants, hardscapes, site structures. That's really the core why behind adopting Revit here.
And that unified model, it clearly helps with the real-time collaboration you mentioned. Architects, civil engineers, everyone on the same page.
Critically important on complex projects.
Okay, so let's dig a bit deeper then into the specific features making Revit attractive for landscape pros. First, topography tools.
Yep. Fundamental.
Our sources mention topose surface modeling for creating terrain. You can use elevation points or import survey data, like from CAD.
That's right. And this is where that intelligence really kicks in again. You're not just sketching contours.
You're modeling the actual surface.
Yes. You can simulate complex grading plans. You can do cut and fill analysis very accurately to balance earthwork.
Which saves money.
Huge potential savings, yeah.
Yeah.
And you create really realistic, data-driven site contours. It's truly building a digital landscape.
Okay, so you've sculpted the earth digitally. Now you need to populate it.
Right.
That brings us to site components.
Right, adding the elements.
So things like plantings, street furniture, benches, paths, parking layouts, using what Revit calls families. For anyone new to Revit, what's a family? Can you unpack that a bit?
Sure. Think of a Revit family as a smart, pre-built digital object.
Okay.
It could be a specific bench model, a particular tree species, maybe a light fixture. The key difference from just a drawing block is that the family carries built-in data.
Like what kind of data?
Dimensions, obviously.
Yeah.
But also material properties, maybe even cost information, manufacturer details.
I got it.
And there's flexibility. You can customize existing families, tweak them, or you can create or import totally new ones for specific project needs. It ensures your digital model actually reflects the real-world components.
Makes sense. And what about the hard stuff? Walkways, plazas, roads, hardscape, and pavement design.
Crucial, yeah. You typically use tools like slabs or floors and subregions to define these areas.
And you apply material definitions, layers. How does that help beyond just making it look right?
Oh, it's massive for downstream work.
Oh.
Applying detailed materials and layers like the base course, the binder course, the pavers,
Okay.
it vastly improves your quantity takeoffs, getting accurate material counts. And it helps with detailing for construction documents.
So accuracy in ordering, accuracy in costing.
Exactly. Revit can automatically calculate the volumes or areas of each layer you define.
Which ties perfectly into the next point. Scheduling and quantification. This sounds like a real BIM superpower.
It absolutely is.
Yes.
This is where you see the benefit of all that data you've embedded.
Automatically generating schedules for plants, materials,
Yeah.
furniture.
This is a huge efficiency booster. It dramatically streamlines cost estimation and procurement.
No more manual counting from drawings.
Exactly. Imagine the software just knows how many of that specific bench type you've placed, or the total area of a certain paving material.
The sources mentioned, this pretty much eliminates a major source of errors and speeds things up significantly.
It really does. Less manual work, fewer mistakes, faster purchasing.
Okay, and then there's the collaboration piece, again, especially on bigger projects. Interoperability with civil 3D and InfraWorks.
Yeah, this is critical for site design.
Linking models, sharing coordinates with civil engineers. How does having that sort of single source of truth change the project dynamic?
It prevents so many headaches, honestly.
Like what?
Well, think about the old way. You might get a building model from the architect, and the landscape team or the civil engineers are almost starting from scratch around it, maybe tracing outlines. It could feel like working in different universes sometimes.
Right, leading to clashes down the line.
Precisely. Clashes, misalignments,
Yeah.
costly rework. Now, with linked models and shared coordinates, everyone's referencing the same 3D space, the same project north.
So alignment is built in.
Yes, architectural, structural, civil, landscape elements all aligned within that single BIM environment.
Yeah.
The accuracy improvement is immense.
And tying that to the bigger picture.
Yeah.
Fewer errors, less rework.
Which ultimately means saving time and money. It's just a smarter way to build, with fewer surprises on site. Less waste, too.
Okay, so we've covered a lot of the how. Let's zoom out again. What are the really big picture advantages of bringing BIM into landscape architecture?
Well, one huge one is consistency across views.
Ah, yes. You change something in the plan.
And it instantly updates in your sections, your elevations, your 3D views, even your schedules.
No more chasing updates across 10 different drawings.
Exactly. Massive time saver, massive accuracy booster.
What else?
Another key benefit is enabling better environmentally conscious design.
How so?
Because Revit allows you to integrate and analyze sustainable features much earlier and more effectively. Think about modeling bioswales for stormwater management, or doing solar studies to optimize planting or plaza design.
So you can evaluate landscape performance right in the model.
Yes, early in the process. That's critical for making meaningful, sustainable choices today.
And then there's the client side. Improved visualization.
Definitely a game changer. Realistic renderings, walkthroughs, generated directly from the model.
Much better for presentations than flat 2D drawings.
Absolutely. You can really help clients understand and experience the proposed space before it's built. It makes the design much more tangible.
And finally, streamlined documentation.
Right, because all the data is in the model, generating accurate, annotated plans, sections, details, and legends becomes much faster.
Less manual drafting, less chance of errors creeping in.
Far more efficient than traditional 2D drafting methods.
Okay, fantastic. So, wrapping things up, we've taken this deep dive into how Revit is really empowering landscape architects.
Yeah, letting them bring outdoor designs to life with kind of the same intelligence and integration we expect for buildings now.
The core value seems to be the data-rich modeling, the better collaboration, and just superior precision overall.
And while, yes, the sources do mention a learning curve.
Especially coming from 2D, like AutoCAD.
Right. But the benefits we've discussed, the efficiency, the accuracy, the capabilities, they really seem to make it a worthwhile investment for landscape architects looking to the future.
It feels like a move from just drawing things to intelligently modeling them, understanding the design more deeply.
Exactly. Understanding the components, the relationships, the quantities.
And it applies broadly, right? designing huge parks, university campuses, complex urban plazas.
Absolutely. Revit offers this powerful integrated approach for modeling, visualizing, and coordinating all those site elements with the architecture. It's a fundamental shift.
Thinking about that unified data model, predicting clashes between, say, underground utilities and tree roots before construction.
Yeah. Or ensuring paving grades work perfectly with building entrances. That's a real aha moment. It's not just drawing better, it's building smarter.
Less waste, fewer surprises on site.
Definitely.
So here's a final thought to leave you with. If BIM can stretch like this, from buildings out into the landscape, integrating everything from soil to site lighting, what does that really mean for how we even define the built environment?
Interesting question.
Does it point towards a future where that line between the natural and the constructed gets, well, increasingly blurred, all managed within one unified digital model?
A future where the entire project site, inside and out, is one integrated system.
Something to think about as we all consider the future of design.